Hello and welcome to Philosophy 100. I try to present most of my lectures in video form so that students can benefit whether they are audio or visual learners. There are also a large number of linked videos throughout the course. Oftentimes I will ask you to pause the current video and watch a video that is linked before moving on. These links are either provided in the module itself or as a comment in the uploaded video on YouTube, or both. Before moving on, I would like to first give a couple notes about the lectures as they relate to the content of this course. The video lectures in this class, much like the lectures in a real-time classroom, both do not necessarily cover every item you're responsible for in the readings. You should always do all the readings. 2, sometimes add material to the course beyond what is in the readings. You're responsible for this information too. This is fairly standard for college courses. Students are expected to do all of the readings, and professors add their own expertise and knowledge to the textbook. Another thing that you should note is that quizzes and tests do not simply test on information you can look up in the index of the book. To do well, you must have thought about the material long enough to apply the concepts. I'm aware that students are able to use their books and notes while taking an online class. A test which only tests on information that can be directly looked up, therefore, doesn't really test students at all. The word philosophy means love of wisdom, with Phil meaning love and Sophie meaning wisdom. Philosophy is a broad and difficult to define discipline. The PH in PhD, regardless of one's major, stands for philosophy. PhD means Doctor of Philosophy. The scope of the discipline has narrowed over the centuries. Originally, all of the sciences as well as mathematics were considered to be part of philosophy. The sciences were originally referred to as natural philosophy. Newton's famous book was, for example, called The Mathematical Principles of Natural Philosophy. Now, philosophy covers 4 primary areas. Axiology, which is the study of valuation. Major topics under this heading include, but are not limited to, ethics and aesthetics, the study of beauty. Metaphysics, this is the branch of philosophy that deals with first principles. Some areas include cosmology, which studies the fundamental structure of the universe. Ontology, which is the study of the nature of existence. There are lots of headings of metaphysics actually, including the philosophy of space and time, some aspects of philosophy of religion, and so forth. It is a very large field. Epistemology. This is the study of the nature of knowledge. This concerns questions such as, what is knowledge? What is justification? And what are the limits of knowledge? Logic, this is the branch of philosophy that studies reasoning itself. There are numerous branches, including but not limited to, formal logic, informal logic, symbolic logic, and mathematical logic. This is a survey course, so we will be dipping our toes into each of the 4 major branches of philosophy, though we may not discuss issues in every sub-branch, and indeed, not all areas of each sub-branch were even listed. That alone would be an ordeal. It should also be noted that the book mentions 3 historical divisions of philosophy. These are different than the subdivisions I just gave regarding modern philosophy. Chapter 1 of the text deals with the nature of philosophical arguments and discusses a bit of logic. This is where we will begin. It is important to understand that when philosophers use the word argument, they do not use it in the sense of fight. An argument in philosophy is, as the book puts it, a series of statements typically used to persuade someone of something or to present reasons for accepting a conclusion. Or, as it was put in the Monty Python sketch, The Argument Clinic, a series of statements designed to establish a proposition. At this point, I would like you to follow and watch the link to The Argument Clinic on YouTube. It is important to follow these links in the middle of the lecture because sometimes, though not always, the content after that point in the lecture will refer to the video. Again, you should be able to find the link for this video in the comments in the module, or both. By the way, if a link is ever broken, please email me about it. The first student who reports any significant errors receives 2 extra credit points. To make use of arguments, both formal and informal reasoning is used. Informal logic, which tends to use natural language, and formal logic, which often uses symbols to represent propositions and conclusions. These symbols are manipulated by a series of truth-preserving rules, much like mathematical geometric proofs. You also need to know these terms. Premise. These are statements used to establish a conclusion. These statements give support for the conclusion. conclusion. This is a proposition that the argument is trying to prove. You also need to understand the difference between deductive and inductive arguments. In my logic course, we go into more detail about the nature of these systems, but deductive logic is about form. These arguments try to show that an argument is valid and sometimes sound. A valid argument is one in which, if the premises are true, the conclusion absolutely must be true. A sound argument is one which is valid and the premises are true, so it follows that the conclusion must also be true. Deductive logic is about form, and if there are no fallacies, the conclusion directly follows from the premises. We say that the conclusion is entailed by the premises, meaning that the conclusion doesn't contain anything that is not already in the premises. The sum is not greater than the parts. The terms valid and sound only apply to deductive reasoning. That is very important, and this is an area many students have difficulty with. Valid and invalid are terms used only for deductive logic. The same is true for sound and unsound. Inductive logic, on the other hand, uses two different terms. Inductive arguments have conclusions that go beyond the premises. For a valid deductive argument, the conclusion necessarily follows from the premises. This is not true of inductive arguments. No matter how strong the inductive argument, the conclusion can be wrong, though often one would have to be delusional to deny the conclusion based on the strength of the argument. These arguments try to show that the conclusion is likely to be true. Inductive arguments are not called valid or sound. Instead, they are called strong or weak. A strong argument is one in which, if the premises are true, the conclusion is likely to be true. The conclusion goes beyond the premises. The premises, if true, strongly support the conclusion, but because one is always making additional inferences or using additional assumptions, the conclusion can always be false. Inductive arguments, when they are strong, can also be cogent, much like deductive arguments, when they are valid, can also be sound. Cogency. A cogent argument is a strong argument in which the premises are warranted or justified and relevant premises are not being ignored. Combined with the fact that cogent arguments are also strong, meaning that if the premises are true, the conclusion is likely to be true as well, this means that the conclusion is likely to be true. While in a valid argument, the conclusion is entailed in the premises, that is to say that the conclusion really says nothing more than the premises do when put together. In an inductive argument, the conclusion goes beyond the premises. Almost all scientific arguments are inductive, not deductive. This is true even when those arguments are exceptionally strong, so strong that one would need to be delusional or uninformed to deny them, such as the shape of the earth. This is because they really make inferences about the world. Again, one should note that even though such arguments could always technically be wrong, even if the premises are true, it is often the case that one would have to be mad to deny the truth of such premises. For example, the fact that the continents move, or the earth is roundish and not flat, are inductive arguments as they rely on measurements and other empirical information which technically could have been wrong, no matter how often they were performed. The terms strong and cogent only refer to inductive arguments, not deductive arguments. Here's an example of a deductive argument. All types of birds have wings. Ducks are a type of bird. Therefore, ducks have wings. This is a valid deductive argument. If the premises are true, the conclusion must be true. While most people can see this, sometimes students have difficulty wrapping their heads around the idea that the following is also a valid argument. All birds are pink. Crows are a type of bird. Therefore, all crows are pink. The above argument is also valid. The difference between the two is that the first argument is also sound, because we have strong reasons to believe that the premises are true. If those premises are true, then the conclusion must be true as well. The second argument is valid, but it is not sound. This is because we know that some of the premises are false, namely, not all birds are pink. However, if those premises were true, then the conclusion would necessarily follow, and that is all that valid means. Here's an example of inductive argument. It seldom snows at sea level in Southern California. I live roughly at sea level in Southern California, therefore it probably will not snow here tomorrow. The above is a strong inductive argument. If the premises are true, the conclusion is very likely to be true. But note that even if the premises are true, the conclusion can still be false. The following is also a strong inductive argument. Sven is a cat. Most cats like loud noises and being splashed with water. Therefore, Sven likes loud noises and being splashed with water. If the premises were true here, the conclusion would be likely to be true also. So this is a strong argument. The difference between this argument and the first is that while both arguments are strong, the first is also cogent. In the case of the first argument, not only does the conclusion strongly follow from the premises, but the premises are highly justified or warranted. The second argument is not cogent. In the second argument, the conclusion would follow strongly if the premises were true, but the premises are not justified. In fact, we have good reasons to think that the negation of the second premise is in fact justified. A note about the book. The book says that informal arguments always use the connective because. This does not mean that they use the word because, but instead that they have a connective implied or something that otherwise fulfills that function. I could say that because it is raining, the grass is likely to be wet, or I could say the grass is likely to be wet since it is raining. The word since in this case is acting like because. Sometimes there might not be an obvious indicator word at all. Language is very complex, and we often use language in such a way that we merely imply what we mean. I might say, for example, can't you see that it's raining? Of course the grass is wet. Premises can also be hidden or implied. The point is simply that such arguments have supportive statements which function as if followed by a because. Arguments from analogy claim that because two or more things are alike in some respect, they are alike in some other respects as well. All arguments from analogy are inductive. Here's an example. Both alcohol and water are liquids. Water absorbs readily into a sponge, therefore alcohol will likely be readily absorbed by a sponge. This would be a strong analogy given what we know about liquids, although some liquids display less surface tension than others and so exhibit less capillary action. Analogies can also be weak. Both a glass Coke bottle and a plastic Coke bottle are clear and similarly shaped. The glass bottle shattered when it fell, so if I drop the plastic bottle it will likely shatter as well. In this case, the analogy is weak, as the shared properties of the shape and clarity between the glass and plastic bottles does not give us a strong indication of how it will react when force is applied. Informal calculus is a specific type of informal argument relating to an action such as what to do, what to buy, or how to act. An argument about what job you should take, or what stock to invest in, or where to go on vacation would be informal calculus. Such arguments relate to something that should or should not be done in the future and usually involve a cost-benefit analysis. This is different from an explanation, which attempts to give a cause for an effect. So, if I say the solar panels are about to stop working because the sun is going down, that would be an argument. If I say you should buy a battery backup storage for the solar panels because they stop working when the sun goes down, that would be an argument and informal calculus. Informal calculus, again, usually involves weighing costs and benefits, but the line in this case is a very thin one. The cost need not be financial, but could be time and effort, or pain versus pleasure, and so forth. If I say the solar panels stopped working because the sun went down, I am giving an explanation. The primary difference between arguments and explanations to remember is that in an argument the conclusion is not yet a fact, or maybe is not yet accepted as a fact by the person being argued to. In the first example, a claim is being made about what will happen to the solar panels in the future. In the second, the author is trying to convince somebody about what she should do. So the conclusion again is not yet an accepted fact, as it both hasn't happened yet, and the purpose of the argument is to convince the reader or listener. In the third case, however, that the solar panels stopped working is both something that has already happened and presumably something that the author does not need to convince the listener of. Instead, a cause is being given for this effect. Both explanations and arguments make use of reasoning. Of course, if the cause is questionable, there could be a great deal of arguing that the cause is the one that the person hypothesizes with the aim of giving an explanation. Because language is complex and messy, the distinction might not always be as clear as we like. Further, explanations can serve as part of arguments, working as premises. So context can matter. On a test or quiz, I try to give clear examples, and perhaps give context as well. There are numerous types of fallacies for formal and informal arguments. We will make reference to some of these throughout the semester. Here's a list of just a few. In my logic course, we cover far more, although by no means all of them. This is just a list of some of them. You can pause here and look at the names and then look them up if you wish. In a logic course, we will cover these directly, while in this class we will discuss the fallacies as they appear. Philosophy makes great use of thought experiments. I give more detail about what thought experiments are in a separate video and also in the appendix to the syllabus. In short, a thought experiment serves much the same function as physical empirical experiments do. It is used to hold certain variables stable and see what differences make a difference to our evaluation, if any. One such famous thought experiment in ethics is the so-called trolley problem. I am linking to a nice video about the trolley problem in the module. This video explains the problem nicely, but also pay attention to any text I give as well. We will be using thought experiments a great deal in this course. More detail is given in the other lecture about thought experiments, but it is important to remember that they are valuable even when they seem unrealistic. In laboratory experiments, the situations set up in the lab are unrealistic as well, but we still learn a great deal from them. And that about wraps up this lecture. Until next time.